Welcome back. In the last session, we covered up to 8 problems. Now write down problem number 9, student workbook problems level 1 from chapter number 4. Refer the figure shown below. Problem number 9. This is R1, PN junction diode. V0, ground. This is your Vi. Okay. This is R1, this is R2. Asking for V0. Okay. Option A, for Vi greater than 0, V0 is minus R2 by R1 into Vi. Option B, for Vi greater than 0, V0 is 0. Option C, for Vi less than 0, V0 is minus R2 divided by R1 into Vi. Option D, for Vi less than 0, V0 is 0. Okay. Let's see. I already told you, if the problem is related to PN junction diode, we should know the status of PN junction diode, then only we can comment on the feedback, right? Because we don't know the status of PN junction diode, then can you say your op amp is in negative feedback? No. If one of the this PN junction diode is in if this PN junction diode is conducting, then only there is a negative feedback. Then you will see what? We will see negative feedback, right? What is the technique to find the status of diodes? Let me call this as D1 and this is D2, right? Open the diodes. The technique is open the diodes to find status. It's their status. Open the diodes to find their status. Okay. When you open, tell me. When you open, your op amp is minus, plus. This is R1 and this is Vi. Okay. Now your diode D1 is open and we have resistor. This is also opened. This is your V0. Okay. Now bring back your diode but don't connect it. Similarly, this is also diode but not connected. This is D1, D2, R2, R1. Okay. Now, if both the diodes D1 and D2 are opened, to find status of D1 and status of D2, that is the technique I told you, right? Now we need to find the voltage across open terminals. Therefore, based on the open terminal voltage, we can say whether D1 is on, D2 is on, or both are on, or both are off, or all the combinations, right? Therefore, now tell me, if both the diodes are off, can I say this is nothing but open loop op amp? Now this is nothing but open loop op amp. When I say this is open loop op amp, what is the next step? We need to use, or we need to consider it as a comparator. When you consider your open loop op amp as a comparator, then let's see. Therefore, now tell me, what is the current which is what is entering into your op amp? Entering into your op amp is 0. The current which is flowing through R1 is also 0. The voltage drop across R1 is 0. The Vi will come here, right? There is no current. There is no current because both are floating. Therefore, what is the voltage here? Don't say 0. Don't apply virtual current concept because your op amp is an open loop. When you open the diodes D1 and D2, therefore it's like a comparator. Now this is nothing but a Vi. This is your input voltage. Then what is the voltage at plus? This is 0. This is nothing but 0. Therefore you can compare and then you will get like that. Okay. Therefore now tell me, if Vi is positive, if VI is positive, then this is positive, therefore this is positive here, this is positive, and when this is positive, tell me, this is the comparator, this is 0, this is positive, then minus is more, then you will get negative, minus Vsat or negative. This is positive, this is negative, your D1 will be conducting. This is negative and there is no current flowing, therefore this is positive, therefore this is positive and this is negative, D2 is not conducting. Therefore, case A, if Vi is positive, D1 is conducting, means D1 is on and D2 is off. Right? Then what is your circuit? If I take the special circuit when Vi is positive, minus, plus or resultant circuit, this is your R1. Now D1 is on. This is what your diode D1, right? And this is what your V0. Then what about right D2? That is floating. No need to have anything, right? Therefore that is floating. D2 is not conducting. This is your D1. Therefore, tell me, is it a negative feedback? Yes. Now it is a negative feedback. If it is a negative feedback, virtual current concept is valid? Yes. Then whatever voltage you have, the same voltage you see here. This is 0. The same 0 is coming at the output. Therefore, what is your V0? Your V0 is equal to 0 volt. When Vi is positive, your V0 is 0 volt. Okay. Now let's see case B. What is case B? Case B, when Vi is negative. When Vi is negative. Therefore tell me, when Vi is negative, this will be negative. Let me use a different color. Okay. Therefore now tell me, this is negative. When Vi is negative, therefore now this is negative. When Vi is negative, this is negative. When this is negative, tell me, this is 0, this is negative, which is more? Plus is more. Then it will be positive. Therefore now tell me, what about D1? D1 will be off. When D1 is off, then what about D2? D2, this is negative, right? This is negative. Now this is positive. Therefore your D2 will be on. Exactly opposite to case A. Therefore, what about D1? Now your D1 will be off. Then what about D2? Your D2 will be on. See, opening the diodes and finding open voltage across open terminals for different conditions and finding the status of D1, D2 and then finding the equivalent circuit and then getting output voltage. Blind technique, easy technique, we will get the answer. Okay, that's why the technique to find the status of diode is open the diode, find voltage across open terminals, then based on the voltage across open terminals we can comment on status of diode. Okay. Now what is your circuit? If this is the case, minus plus, then this is your R1, this is your Vi. Therefore tell me, D1 is off, this is off, D2 is on. Therefore this is your R2, this is your V0. Therefore if this is the case, what is your V0? Your V0 is equal to minus R2 divided by R1 into Vi. Therefore tell me, what is the answer? If Vi are, instead of responding to answer, if you ask me the transfer curve, x-axis is Vi and y-axis is V0. Problem is over, we can solve the problem, but I am just asking, converting into a graph. The graph is representing the action or the relation between Vi to V0. Tell me, if Vi is positive, output is 0. If Vi is positive, output is 0. When Vi is negative, your output is minus R2 by R1 into Vi. I can say this minus R2 by R1 is a slope. Y is equal to mx, right? When Vi is negative, this is negative, your V0 will be positive, right? When Vi is negative, your V0 will be positive. But as Vi is increasing, therefore you will get like this, negative slope basically. The slope is the slope of this curve minus R2 by R1. This is the slope. Okay, this is what is called transfer characteristics. You got transfer characteristics between V0 and then Vi. Okay. Therefore, tell me what is the answer? If Vi is positive, your V0 is 0. If Vi is negative, your output is minus R2 by R1. We have two options. Remember, this is GATE 1990. Sorry, GATE 1989. Therefore, earlier that time, not only one option, multiple options are true. Therefore, when Vi is positive, this is also true. When Vi is negative, therefore, the moment you say this is happened, this is happened, then don't take only option B. We have to see all the options. I think when Vi is negative, your output is minus R2 by R1. Both the options are true. Actually, this is difficult. If you know that definitely one of the options is correct, then once you come across the options, from the options, we will choose that. We will not think about other options. But remember here, until unless you know completely about the problem, then we cannot say, therefore we should know why this is correct, why this is correct, why this is not correct, why this is not correct. We should know all the options related to your problem. Once you solve a problem, if you get the answer, fine. But that answer and then multiple answers if you have, then we need to solve the problem in different angles and all possible combinations. That is difficult. But nowadays only one option is true out of 4 options. But earlier you can have one option true, 2 options true, 3 options true, or all the options true. We don't know, right? Problem is over. This is what is problem number 9. I'll give you 30 more seconds. Try to complete in 30 seconds. Then we'll go to level 2. Level 1 problems are over. Now we can go for level 2. Before going to level 2, okay, let me complete something here. Therefore, what is the meaning of this? For example, if I give a sine wave, let us say this is what your input signal. Okay, tell me what is your output. See, if a circuit is given, once you represent your circuit with a transfer curve, we don't need circuit. The transfer curve is enough to find what is your output for any given input. Therefore, tell me, what does it mean? If Vi is greater than 0, what is your output? Your output is 0. If Vi is positive, for positive values of your input, what is your output? Your output is 0. Your output is 0. Now, when input is negative, right? What is your output? Your output is tracking your input with the slope of minus R2 by R1. And input is negative, therefore your output is also, slope is negative. What do you get? You will get it, right? Minus into minus. Plus, maybe that depends on the slope, how much you multiply, what it may be. This is what you get. What is this? This is nothing but half wave rectifier. But for the negative cycle of your input, you are getting positive cycle in the output with some gain. Whatever gain you want, you can get it. Therefore, this is what is called precision rectifier. This is what is one of the precision rectifier. This is what is one of the precision rectifier. What is precision rectifier? how much gain you want, in what angle, with respect to what phase, with respect to what voltage you want to have the rectification, we can get it. Therefore, we can process your sine wave and then whatever you want to get at the output with respect to some threshold, we can get it. Okay, that is what is called precision rectifier. Okay, draw it. Remember, once you know the transfer characteristics, then for any input, not only sine wave, square wave, trapezoidal wave, piecewise linear, ramp signal, sawtooth waveform, for any type of input signals, we can get the output blindly without applying the type of signal to actual circuit. Okay, I am going to use that technique later. Wherever there is a diode problem, I will not respond actually to the type of input, whether it is sine wave or what. I will just take it as Vi. Let's sweep Vi from minus infinity to plus infinity. Try to get V0, then respond to actual input. That will give you accurate answer without any confusion. Right? That is the technique. See, this is not asked, but I am just giving you the theory behind it. This is nothing but a rectifier. Now, level 2. Problem number 1. Hope this is done. Okay. Problem number 1. Assume that the operational amplifier in figure is ideal, then the current flowing through 1 kilo ohm resistor is this is 2 milliampere. For asking for the current, which is what is flowing through 1 kilo ohm. Therefore, what is I? This is fill in the blank. What about plus? Is it floating? No. It is connected to ground. Okay. Now, negative feedback or positive feedback? Negative feedback. Virtual ground concept is valid? Yes. Remember blind techniques. Okay. 0, 0. Apply nodal analysis, you will get the answer. Simple. You will get the answer, no doubt. But you may need to apply 2 nodal analysis. Let us say this is what is our voltage. Let us say this is what your output voltage V0. Okay. Now, then we need to see KCL. What it will be? Let's see. Right. Now tell me, this is what your 0. Right. Now, if you apply nodal analysis, you get the answer. Apply nodal analysis. Current leaving from this node. What is the current which is leaving from this node? Actually, current is entering. Therefore, what is the current which is leaving from this node? Minus 2 milliampere. Minus 2 milliampere plus current leaving from this node. 0 minus V0. Current leaving from this node divided by 2K is equal to 0. I hope everybody understood. Therefore, what is the current which is leaving from this node? This is nothing but minus 2 milliampere. Because if you apply nodal analysis, we should know the current which is what is leaving from this node plus the current which is leaving from this node. That's it. Therefore, don't write 0 minus 0 by resistance, not like that. Therefore, current leaving from this node is known to you already. That is nothing but minus 2 milliampere, and current leaving from this node is nothing but 0 minus V0 divided by 2K. That is what is the current. Okay. Therefore, it is equal to 0. Then if you take to right hand side, your V0 by 2K is equal to minus 2 milli. Then what is your V0? Your V0 is equal to minus 4 volt. Take this as equation 1. Now you got what is V0. Therefore, this is nothing but minus 4 volt. Now apply KCL. Right? What is KCL? We know the current which is what is flowing through this. What is this current? Actually, this 2 milliampere is coming. KCL. What is the current entering into op amp? 0. Therefore, this 2 milliampere is, it has to flow. There is no other way. Therefore, now this is what is 2 milliampere. Now, when I say this is 2 milliampere, we cannot apply nodal analysis here because we don't know the voltage at the output of op amp. It could be anything. Op amp will supply such that it satisfies KCL and KVL. Now what I do, I will apply KCL. If I know this current and if I know this current, can't I find the current which is what is flowing like this or coming out, right? Therefore, now when I say that is what your 2 milliampere, okay, then tell me what is this current. Let us say this current is nothing but I1. Okay, then tell me what is the current I1? To find I, what is I1? Therefore, I1 is nothing but V0 minus 0, the drop across this divided by 2K. Therefore, what is I1? I1 is nothing but minus 4 divided by 2K. Therefore, minus 2 milliampere. That is what is your I1. Okay. Therefore, now tell me. Therefore, KCL. KCL at output node. At output node. Therefore, tell me KCL. This current is equal to this current plus this current. Therefore, what is that current? 2 milliampere is equal to the current which is leaving from this node is I1 plus the current which is what is leaving this node minus I. I am just taking like this current is equal to this current plus this current. What is this current? Opposite to the representation which is minus I. That is fine. Therefore, what is your I? I, if you take this side and then I1. Therefore, what is your I? I is equal to I1 minus 2 milliampere. What is I1? We got to know that minus 2 milli. Therefore, minus 2 milliampere minus 2 milliampere. You will get minus 4 milliampere. That is what is your current I. What is the answer? I is equal to minus 4 milliampere. See, I just applied KCL. That's it. Okay. And used virtual ground concept because it is in negative feedback. Take it. Done. Problem number 2. For the ideal op-amp circuit shown in figure, determine the output voltage V0. Okay, circuit is the connections, wires, right, resistors, they are given to confuse you, but whether it is confusing you or not doesn't matter. We should know only one thing: negative feedback or positive feedback or open loop. Surely it has some feedback, therefore either negative feedback or positive feedback. Surely we can say that it is negative feedback because your output is sampled and then fed back at the input side. Therefore it is fed back at the input side and it doesn't have any positive feedback. Looks like it is having some connection to the plus. No, it is only having negative feedback. If it is a negative feedback, can I apply Watts-Wagon concept? Yes. Therefore, do you know what is the voltage at this point? We don't know. Therefore, let me call this as VA. This is also VA. Apply nodal analysis at both the nodes. You will get the answer. That's it. Okay. You can take this as a reference. Let me take this as a reference. When I take this as a reference, then voltage at this point with respect to this reference. Therefore, now tell me, VA minus, apply nodal analysis at this node. VA minus, what is this voltage? 4 divided by 100 ohm plus VA minus V0 divided by 99 ohm, right, plus current leaving from this node, plus current leaving from this node, plus current entering into op-amp, 0, doesn't matter, this is 0, right. Therefore, now tell me what is your VA. If you take VA common, you will get 1 by 100 plus 1 by 99, right, minus 4 by 100, which is 1 by 25, is equal to V0 by 99. You take this as equation 1. Even you take this is approximately 100, doesn't matter. Okay. Now apply nodal analysis at the other node. What is that? VA minus 4 divided by 100 ohm plus VA minus 0, that is your reference. VA minus 0 divided by 100 is equal to 0. 100 will be cancelled. Then 2 VA is equal to what? 4. Then VA is equal to 2 volt. Equation 2. Therefore, 1 implies, what is your V0 by 99? Can I take 99 approximately equal to 100? Even if you take 99 approximately equal to 100, doesn't matter. Okay. Or if you take, therefore, what is V0 by 99? V0 by 99 is equal to, VA is nothing but 2 into 1 by 100 plus 1 by 99 minus 1 by 25, right? Therefore, what is your V0? Your V0 is equal to 2 into 99 by 100 plus 1 minus 99 by 25. Even if you did take it as approximately 100, then what you get? This is nothing but 100 by 100, 1 plus 1, 2, 2 into 2, approximately 4 minus 100 by 25. 100 by 25 is nothing but what? 4. Therefore, this is also approximately 4. If you take it approximately 4, then you will get approximately equal to 0. Therefore, what is your V0? Your V0 is approximately equal to 0. If you want to calculate exactly, you can calculate exactly also. What is that? 2 into 99 by 100. If you do that, I will tell you what is the exact value. Okay? 99 by 100, 0.99 plus 1 into 2, which is nothing but 3.98. 99 by 25, 3.98 minus 3.98. That is 0.02. If you calculate exactly, you will get 0.02, which is 20 millivolt. Okay? Maybe if you want to calculate, exact value is nothing but you will get 20 millivolt, which is nearer to 0. But the exact value is 20 millivolt. Okay? Because why we are calculating exact value, it is fill in the blank. If this is fill in the blank, it's better to calculate accurately. Okay? If it is multiple options, based on the options we can say whether we can go ahead with approximation or we need to calculate exactly based on the options. But here options are not given, therefore whatever you write, that will be correlated to the value which is what is given in the key, then definitely it should match at least 2 decimals. I hope this is done. Problem number 3. The output voltage V0 is, for problem number 3, minus plus this is 2 volt, 5 kilo ohm, 10 kilo ohm, 100 kilo ohm, 10 kilo ohm. Okay? Then option A minus 4 volt, option B 6 volt, option C 5 volt, option D minus 5.5 volt. Therefore asking for V0. Okay, tell me, negative feedback or positive feedback? Actually, it has both the feedbacks. Then I told you what to do. If the op amp is having both the feedbacks, don't blindly apply virtual current concept. Officially, we need to solve. Okay, we need to confirm. I told you there are two loops. If there are two loops, positive feedback loop and the negative feedback loop, open the loop and then find. Therefore, what is the technique? Technique is open the loop. When you open the loop, okay, now let's see, increase the output voltage by 100%. If you increase the output voltage by 100% and come back and then see what is the change here or which is dominating, minus or plus. Now tell me, this is nothing but what is your feedback factor in the positive feedback? If it is 100%, how much is the increase here? How much is the increase? We need to calculate. What is that? Therefore, for the positive feedback, what is your beta? Your beta is equal to the sampling point. 10k divided by 10k plus 100k, 110k. Kk will be cancelled. It is 1 by 11. That is our beta. What is negative feedback factor? If you take negative feedback, means if this is increasing, this will also increase. Then remember, you have to take it ground, because we want to know the change here only because of the change here. We have to ignore, or we have to make this 2 volts 0, because I want to find the change here only because of this. Therefore, now tell me what is your beta? The beta is equal to 5k divided by 15k. Kk will be cancelled. It is 1 by 3, which is having more sampling. Therefore, this is also beta V naught sampling here. Here beta V naught sampling. Therefore, if you observe clearly, therefore your negative feedback is dominating. This is what is 33%. Therefore, it is increasing 33%. But this is what is increasing by less than 10%. Therefore, you can say 9%, approximately 9%. Therefore, which is dominating? Your minus is dominating. Then your output will decrease. Therefore, negative feedback or positive feedback? Negative feedback. If this is a negative feedback, therefore, overall, this is a negative feedback. If this is a negative feedback, virtual ground concept is valid. Virtual ground concept is valid. Okay. Then apply nodal analysis. The moment you know that virtual ground concept is valid, apply nodal analysis, you'll get it. Okay. Don't disturb the original circuit. You draw it and then open and then try to represent. Then say that it is negative feedback. Virtual ground concept is valid. Then apply nodal analysis. You'll get the answer. Okay. What is beta? Beta is nothing but sampling factor. Negative feedback, sampling factor. Done? Okay. Now, negative feedback. If it is negative feedback, let's go back to the original circuit. This is 5k. This is 10 kilo ohm, 100 kilo ohm. This is 10 kilo ohm, 5 kilo ohm. Now this is what is 2 volt. See, while finding, we have to make it 0. Okay, that's fine. Therefore, apply nodal analysis. If you apply nodal analysis, we know that virtual ground concept is valid. Therefore, let us say this is VA. Then what is this voltage? This is also VA. Then apply nodal analysis. VA minus 2 divided by 5K plus VA minus V naught divided by 10K plus current entering into op amp, that is 0, is equal to 0. Multiply with the 10K, then KK will be cancelled 10, then 2VA minus 4 plus VA is equal to V naught, right? Therefore, what is VA? VA is nothing but, okay, VA is nothing but V naught plus 4 divided by 3. This is what is equation 1. Now, apply nodal analysis at the other node. Therefore, tell me, VA minus 0 divided by 10K plus VA minus V naught divided by 100K plus current entering into op amp, that is 0, is equal to 0, right? Multiply with KK, multiply with 100. When you multiply with 100, 10 VA plus VA is equal to V naught. Therefore, what is V naught? V naught is equal to 11 VA. And what is VA? VA is nothing but 11 into V naught plus 4 divided by 3 from 1. Right? Then if you take V naught common, what you will get? For if you take V naught common, 1 minus 11 by 3 is equal to, you will get 11 into 4, 44 by 3. Then if you take 3 common, then you will get V naught, 3 minus 11 is equal to, by 3 will be cancelled, 44. Then what is our V naught? V naught is equal to minus 44 divided by, what is 3 minus 11? 8. Then what is this? This is nothing but minus 5.8 5s are 40 dot 8 5s are 40 minus 5.5 volt. What is V naught? Option D. I hope everyone understood. See, simple negative feedback problem, but it has both the feedbacks. If both are having feedbacks, then we should find the type of feedback by opening the loop. Then which one is dominating, that we can find by having the variation. Then which is dominating, minus is dominating, therefore it will decrease. Then overall, if you see, that is negative feedback. Once you know that it is a negative feedback, Workbook concept is valid, then apply nodal analysis. Then apply nodal analysis at both the nodes. Then solve the equation, you'll get the answer. That's it. Okay, take it. Okay, if this is over, then we will continue to the next session. Time is almost done. In the next session, we will see problem number 4 from level 2. Okay, thank you.